Hello, in this video I would like to show you how to find the arc length of the graph of function on some interval, okay? But firstly, let's consider a very simple example. When we have the curve as a straight line, okay? So I have a straight line, and on this straight line I have 2 points A and B. A is x1, y1, and B is x2, y2. Let's remind the formula of the distance between A and B. So we should know that from pre-calculus or calculus 1 or even at high school. So the distance between A and B is square root of x2 minus x1 square plus y2 minus y1 square. You see? Or we can write in the following way. Alright, this guy is just delta x, right? So I have delta x squared here. Plus, this guy is delta y. I have delta y squared here. So this is equal to square root of delta x squared plus delta y squared. Everything is good with, with the distance between 2 points on a straight line. And now, if you have 2 points on some curve, okay, and I really want to find arc length. So how do that? Suppose this is A and this is B, okay? So in order to find the arc length of this curve, we have to split this curve into small pieces. That is the whole general idea of integration, right? If you split this into small pieces, so like, let's say in this, right? I have small piece in here. Let's say this is delta x, and this is, just AI and AI plus 1. So I can approximate, the arc length of this guy by the distance from AI to AI plus 1. Because when AI and AI plus 1 are very close, this curve is very close to the straight line. So that's why we can approximate the arc length of AI plus 1 by the distance from AI to AI plus 1. Okay, let's do that, right? On this subinterval, so I have SI means the distance between AI and AI plus 1 is square root. It is square root of what? Of delta xi square, okay? Plus delta I square. Because, we are considering on this interval xi and xi plus 1, right? So now we sum them up. We get some Riemann sum in here. And I from 1 to n, okay? And then we'll do some limit process. I'll write here limit of this guy n delta xi square plus delta yi square when, usually we use the norm of xi, the maximum, right? This guy goes to 0. So in this situation, we will get the exact arc length from A to B. And that is the exact arc length. And this is the definite integral. But in order to find the integral, we need to do one more step, okay? Because, usually when you do that process, you would need to change dx to delta x to dx, right? But in this formula, we still don't have delta x. So basically, I need to pull delta xi square out of the square root, right? And then I will take the limit process. So this is just, I from 1 to n in here, and I put delta xi square out of the square root. So I only have delta x squared. In here, I have 1 plus delta xi over delta y over delta xi squared. Okay, and when you consider limit, we have this part, equal to f derivative of x. So our integral will look like integral from a to b square root of 1 plus f derivative x squared in here, and then dx. And this is the arc length. You see, the idea is very simple. First, we split, right, our curve into small pieces, and then we approximate the distance, the arc length on each subintervals by the distance between two endpoints. Then we sum them up, and then we consider some limit process. Finally, we get some definite integral. Okay, and now let's consider one example, how to apply this formula. Okay, example 1. Let's find the arc length of the graph. Of the function y equal to ln of cosine of x on the interval 0, pi over 4. Okay, so let's make the graph of this function, and then we'll see I have x in here, I have y in here, 0 in here. We consider this function on 0 to pi over 4. Here's pi over 4, okay? The function at 0 is 0 because cosine of 0 is 1 and ln of 1 is 0. The function value at pi over 4, so you see at pi over 4, the function will equal to ln of cosine of pi over 4, right? Cosine of pi over 4 is square root of 2 over 2, which is less than 1. So basically that is ln of square root of 2 over 2, which is less than 1 somewhere in here, right? Less than 0, sorry, somewhere in here. So I have another point in here. So I connect the origin with this guy. I have the curve, and we need to find the arc length of this, all right, on 0 to pi over 4. Now just apply the formula. So by the formula we have the arc length is equal to integral from 0 to pi over 4 square root of 1 plus f derivative x squared dx. So in this problem we need to find the derivative, right? So let's do that. Where f derivative of x is equal to ln of cosine of x derivative. So here we need to use the chain rule. Let me remind you the chain rule, right? The chain rule for this guy says ln of u prime is equal to u prime over u. Okay, chain rule. So if we use this formula, I will get u prime is cosine of x prime over cosine, that is negative sine of x over cosine. Now I just substitute this into the formula. So the arc length is equal to integral from 0 to pi over 4 1 plus sine square of x over cosine square of x dx. the derivative has negative in here, right? But when you apply square, so the square of negative just plus. So that's why I don't write negative in here. Okay. What is sine square over cosine square? That is just tangent square, right? So we know that is equal from 0 to pi over 4 integral from 1 plus tangent square of x dx. And if we remember, 1 plus tangent square, what is that? 1 plus tangent square is just secant square. So I will rewrite this integral as 0 to pi over 4 square root of secant square of x dx. Okay, so here, square root of secant square, I need to write separately, right? Because that is, common mistakes. When you have square root of secant square of x, that will be absolute of secant of x. So we cannot write just secant of x, right? But what is the absolute? The absolute function, that is positive when the inside is positive, and negative of that guy if the inside is negative. So, but we are considering the function on 0 to pi over 4 in here. And on this interval, all, elementary trig functions are positive, like tangent, cotangent, secant, cosecant, sine, cosine. So in this situation, I can write that is just integral from 0 to pi over 4, and then here I have secant of x dx. Because secant is positive in this case, right? Equal to secant of x. I write here on 0 to pi over 4. So we can use the formula sheet, and that is, antiderivative of secant is ln of secant of x plus tangent of x, right? And this evaluated from 0 to pi over 4. Now you plug pi over 4 and 0 into this formula, you get ln of secant pi over 4, right? Plus tangent of pi over 4 minus ln of secant of 0 plus tangent of 0. And this is equal to square root of 2. This is equal to 1. So you have ln of this guy plus 1. Secant of 0. What is secant of 0? This guy is just, 0. This guy is just 1. Right? So you have ln of 1 plus 0 in here. Of course, this guy is 0, right? So minus. So finally, the final answer is ln of square root of 2 plus 1. Now, let's consider the second example. Let's find the arc length of the graph of the function y equal to 4 over 5, x to 5 over 4 on 0, 16. Alright, so as we have seen that, the first thing we need to do is find the derivative, right? Find y prime. Because in the formula, we would need a derivative. So let's find y prime. That is equal to 4 over 5, okay, as a coefficient. And then for this, we use the power rule. We'll bring the power down, and then we reduce the power by 1, okay. So, it's very good. 4 with 4, 5 with 5 will be cancelled out. So finally, we have x 1 over 4. All right, so now we can substitute everything into the formula. The arc length is equal to integral from 0 to 16 square root of 1 plus y prime square, means x 1/4 square dx. You see, so yeah, this integral looks very interesting. It's from 0 to 16 square root of 1 plus x 1/4 square is x 1/2. Okay, so this guy is just x 2/2. But x to 1/2 is square root of x. So I just write in short, square root of x dx in here. the integral looks difficult, right? So we need to do some substitution in this situation. All right, so let's put u equal to 1 plus square root of x. You know, the reason why I do this, because we know how to integrate, how to work with square root, right? How to work with the square root in here. But in here, I have 1 plus square root of x. So basically, I probably need to do substitution u equal to 1 plus square root of x. So that's why I put u equal to 1 plus square root of x. And try to rewrite this the original integral in term of u, okay? But before that, you know, usually when we do substitution, we differentiate right away, right? But in this situation, I will do in another way. I will solve this equation for the x, okay? From here, I get square root of x is equal to u minus 1, and then x equal to u minus 1 square. Only after this, I differentiate. So I have dx equal to 2 times u minus 1 du. Now, I will rewrite the original integral in terms of u, but I will not take care about the integration limits because I will use, you know, I will plug all numbers back at the end, right? So I just need to find antiderivative. So my integral from 1 plus square root of x dx is equal to square root of u, because we already put u equal to this function, okay? That is u already. So I have square root of u over there, and then dx is 2 times u minus 1 du. You see, now it seems better, right? It seems to be better. And I have this equal to 2 times integral of square root of u, I will rewrite as u to 1/2, and then u minus 1 du. We have all power functions in here. That's good. We have integral u 1/2 times u minus u 1/2, and then du. I just distribute this, okay? And I have two power functions in here to integral 1 u to 3/2 minus u to 1/2 du. And then now I use the power form for integrals. I get 2 times u to 3/2 plus 1 over 3/2 plus 1 minus u 1/2 plus 1 over 1/2 plus 1, okay, plus c. You see, it looks not really bad, right? And that is 2 times, you know, we have u 5/2, and then here we also have 5/2 minus u 3/2, u to 3/2, and then here 3/2 plus c. Now let's simplify that, right? So we divide by 5, half means multiply by 2 over 5. So basically I have 4 times in here. In here I have u 5/2 over 5, okay, and then minus u 3/2 over 3 plus c. And then I have to bring x back here, right? So since we already put u equal to 1 plus square root of x, so I have this is equal to 4 times 1 plus square root of x, 5/2 over 5 minus 1 plus square root of x, in here 3/2 and over 3 plus c. Yeah, you see, this is antiderivative of our function. It looks really big, right? And then now we just plug where's our original integral. The original integral in here, we just need to plug 0 and 16, right, into this antiderivative. So I can find the arc length is equal to 4 times in here, and I plug, you know, 1 plus square root of 16, and here 5 over 2 over 5 minus 1 plus square root of 16 to 3/2 over 3. All these things, subtract by 4 times. 1 plus 0 square root over 5. In here, power 5 over 2 minus 1 plus 0 square root 3 over 2 over 3. And of course, please use calculator to find this number. But in my course, I really don't need the exact value of this. If you get this step, you already get full credit. On other things, just the problem with calculator. Okay, so I hope that this video is helpful and would help you to prepare to test better. Thank you for watching.